Hey everyone, in this video we are going to continue working with subsystems and commands. So in this video we are going to sort of extend all of the work we did with tank drive, right, in the previous video, and we're going to extend that to talking about coding and intake, alright? So here's the idea behind an intake, right? If you're not familiar with that term, or we've thrown it around already, so hopefully it sounds familiar, but in any FRC game in general, there's the idea of needing to acquire a game piece, right? We need to somehow pick it up, right? Whether it be a ball, a cube, a cone, some kind of object. You need something, some kind of mechanism to pick it up. And in general, that mechanism usually has a bunch of wheels on it, and in most cases, it's usually two sets of wheels, all right? And so in this video, we're just going to make an assumption that our intake is this set of roller wheels, and there's two of them, right? Or in this case, we're actually just going to assume that there's one of them, right? There's going to be one motor responsible for an intake, all right? And that motor controls a set of wheels that spins inwards to pick up a game piece, all right? That's the idea, okay? So in order to get started, the first thing that I want to do is actually just go ahead and first make the subsystem, all right? I'd kind of like to just get that out of the way. So again, you're just going to right-click, create new class command. It's going to be a subsystem, and we're going to call this intake subsystem. Okay, and there we go. We've got our intake subsystem nicely set up. Okay, now the next thing we're going to want to do, right, is initialize our motor, right? So we're going to initialize the intake motor, all right? So that's going to be private. Right, private attributes in a class. We're going to talent effects. We're going to have an intake motor equals new talent effects. Hopefully this is straightforward. Now we need to pass in the ID. So instead of just manually writing out what the ID is, instead let's just define some constants for it, like we kind of did for our tank drive, right? So let's head over to the constants folder and make a new static class. All right, so it's going to be public static class, and let's call this intake constants. All right. Cool. So the first thing we're going to want is an intake motor ID. So let's do public static final int intake motor ID is equal to, let's say in this case 5. All right. Then, all right, since we're already here, let's go ahead and define the configuration that we want, right? So the default configuration for the motor, oops, sorry about that. The default configuration for the motor, as well as a current configuration. So kind of like the exact same thing we did for the tank drivetrain, all right? So if anything, I'm just going to copy this since you should already have it and just paste it in just to save some time, all right? But it's just this code right here. We apply the same configuration in general for all our motors, all right? So that is pretty much it, all right? So the next thing that we're going to do is actually configure this, right? So now we have a constant we can use, so we can do intake constants dot intake motor ID. All right, so you'll notice, right, that we do have an error, and if you're wondering what it is, or if you haven't realized already, it's because it's not imported, right, the talent effects library. So we're gonna import it. All right, that's the quick way to resolve it. No need to write out that import statement, just hit the quick fix and it'll do it for you. All right, so once you've initialized that intake motor, all right, let's set it up, right? So now it's easy, right? Now we can just do intake motor.getConfigurator.apply, and then it's going to be intake constants.configs, right? We know that this is indeed the factory default configuration, right? It's just the same thing. It's just stored in a constant, so it looks cleaner, all right? So let's just write a comment there just so we know what it's doing. So it's going to be configure the motor's factory default settings, all right? And then, right, we're going to apply a current configuration to the motor. So apply a current configuration to the motor. Okay, it's going to be intake motor.getConfigurator.refresh first, and it's going to be intake constants.current limits. All right, now if you're wondering, right, and we kind of glossed over this before, but if you're wondering why we need this refresh, in actuality, in this case, we don't. But when you get to more advanced motor control, right, there might be a moment, or rather a time, where you need to modify the configurator, all right? And that's this configurator right here, right? The configuration on the motor. There might be a moment in time, and again, I'm talking about an instance that's outside of the setup period, right? There might be a time, maybe when your mechanism is doing something different, that instead of changing the setup in this constructor, you have a method that does it instead, right? And you have to do it during a certain condition, right? In that case, calling refresh on a specific configuration will make sure that none of the other configurations accidentally end up changing. Because what you might end up doing when you actually don't call refresh, or if you change the configuration midway through a mechanism's course of action, right? What could happen is you might lose other configurations. So refresh will make sure that it's only looking for the current configuration, or rather this configuration that you supply it, all right? So that's why we use refresh. In this case, not super necessary, but it is a good practice, all right? So then we're gonna do intake motor. We have to apply the configuration, right? So .get configurator .apply, and it's gonna be intake constants .current limits. Okay, cool. So that is all you need to do in terms of configuring the motor, all right? The next step is to define some setter methods, right? Now, in this case, we only have one motor, and this motor is going to run with the percent output. So the method's actually pretty straightforward. It's just going to be public void run intake. Okay, and then double set point. Okay, and then we're going to do intake motor dot set, and then at the set point that we pass in. Okay. Now, one thing that I like to do, and you don't need to do this, is add a Java comment. So if you do the forward slash and then 2 stars, VS Code will kind of auto-populate it for you. So let's label this with as a method to run the intake at a particular set point. And I'll show you why this is kind of cool in a second. At param set point, the percent output at which the intake should run. Okay, that's detailed enough for me. Nothing, actually, in terms of periodic, let's just have a smart dashboard printout. So smart dashboard dot put number, intake percent output, and then it's going to be intake motor dot get. All right. And yeah, that's pretty much it for the subsystem. Okay, so now, right, let's go to a command. So we're going to define 2 commands for this intake, all right? The first command is going to be running the intake inward so that we can acquire the game piece. The second command is going to run the intake outward so that you end up ejecting the game piece out of the robot, all right? So the first command is going to be the run intake command. So the standard, run inward, all right? So we're going to call this run intake command. Okay, now, right, remember, you have to declare your subsystem first. Not initialize, but declare, all right? So declare, first what we're going to do is declare the intake subsystem. Okay, and this is going to be private intake subsystem, Okay, cool. And then from there, we're going to do add requirements, but remember, we have to actually initialize this within our code, so we need to take in an instance of it, so it's going to be intake subsystem, and then what we're going to do is say this dot intake subsystem is equal to intake subsystem, now we've initialized it, and then add requirements on this dot intake subsystem. Okay, all right, so the only thing we're going to do in this is just run the motor at negative 0.5% output, all right? So it's just going to be intake subsystem, and we're going to call the method we made, so run intake, and then negative 0.5. Now here's why that sort of documentation is cool, all right? Because if we hover over it, look, I now in VS Code can see that, okay, this is a method to run the intake at a particular set point, the only parameter is the set point, and that is the percent output at which the intake should run. So it's kind of convenient, like if you're debugging or something goes wrong, you can see what your methods are doing, and this can really give you a boost in terms of, all right, okay, this method's doing this because I just hovered over it and read it instead of, okay, needing to control click and then look at the method, and, kind of a nightmare. All right, so that's it for this command. Now, for the next one, it's just going to be an intake eject command. It's going to be very similar. It's just that instead of running it at negative 0.5, we're just going to run it at 0.5 instead. All right, so intake eject command. All right, again, same idea, right? So the first thing you're going to want to do is declare your intake subsystem. So we're going to declare the intake subsystem. Okay. And then this is going to be a similar idea, right? So, oh, I actually forgot to write that. Okay, there we go. All right, so private intake subsystem. Then we need to take in an instance of it. So it's going to be intake subsystem. You can call this whatever you want. This keyword will fix all of that for us in terms of them having the same name. Then we do add requirements, this dot intake subsystem. Finally, inside execute, we're going to do intake subsystem dot run intake for 0.5% output. Okay, all right. So that's pretty much it in terms of our commands. Now let's take a look at robot container, all right? So the first thing that I want to do, right, is sort of just go through the process for binding the buttons, but I'm going to do it for the case where if you don't have an Xbox controller, all right? So for me, right, I kind of have this generic off-brand controller, right? And so it's not an Xbox controller, it's actually a Nintendo Switch controller that I got off Amazon for like 15 bucks. But so what I'm going to do is sort of walk you through the process of basically, binding buttons from scratch, all right? And I'm going to do it for the case where you don't have an Xbox controller, right? So I just plugged in my controller. Let's open up Driver Station, and this is generally the first thing that you want to do. Driver Station should open up. It might open on my other screen, so I'll just drag it real quick. Let's see. Come on, Driver Station. Open up. Okay, yeah, let me drag it over here. Okay, cool. So, all right, it sees that we have a joystick plugged in. So, if I go to my joystick real quick, right, you can kind of see it's a wired controller for Nintendo Switch, right? So what I want to do is just figure out which buttons I'm going to use, all right? So in this case, let's use the plus and minus button on the Nintendo Switch controller, all right? So you can see that we have these buttons highlighting as I press them, right? So this is the plus button. You can see that highlighted. And this is the minus button, all right? Now, in order to determine what the button is, I believe it is going 1 through... it starts at 1 and then goes down. So it's going to be, in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right? And then this one's going to be 9 corresponding. All right? So let's just keep that in mind as we sort of write our code. Now, instead of using a command Xbox controller, right, you're just going to use a command joystick. All right? So it's just going to be private final command joystick. And then I'm just going to call it alt driver joystick, all right, is equal to new command joystick, and it's in port 0 for me, all right? Now, actually, this is already port 0, so I'm going to change it to port 1. If you want to change driver station ports, right, and by port, I mean in what USB order it's in, right, you can kind of just drag it like that, all right? So now, my controller's at port 1, all right, so I won't have any conflicts. Okay, so we sort of initialized our joystick, right? But we also have to initialize our subsystem, okay? So private intake subsystem equals new intake subsystem. Cool. Okay, so now in configure bindings, here's what you can do. All right, so it's going to be alt driver joystick dot get, let's see, where is the button that what function that okay, dot button, right? And the button we specified was 10, right, for the plus, dot, and then we're going to do on, or let's do while true, all right? So while we hold down the button, we're going to do new run intake command and pass in the intake subsystem. VS Code auto completes that for us, all right? So I got the button, right, and I found the ID by looking at driver station, okay? And then while it's held, I'm going to run the intake command, all right? Now, that's for the plus, right? So here, I'll type it here. Plus button on alternate controller. Okay, now let's do the minus button. So let me just comment that in. Minus button on alternate controller, okay? And then we're gonna do alt driver joystick dot button. It's gonna be 9. Hopefully I did that correctly. And then while true, new intake eject command. And I forgot to add one more thing in the command that'll make sure that we can use to make sure it's running. So let's just go back and add it. Here inside execute, I just want to write a smart dashboard printout. So smart dashboard dot put string, and then it's going to be we're gonna call, let's just call it intake current state. And then here we're gonna type in inward, right? And then we're going to do the same thing with the same key, all right? So hopefully what should happen is the same box should change, all right? That's the goal. Sometimes shuffleboard can be finicky and that might not happen, but we can try it, all right? So we're going to put string. Again, we're going to use the same key. Oops, I double-coded there. All right, intake current state. And then, forgot to close it. Okay, intake current state. And then this one is going to be ejecting, all right? Okay, so that should be it in terms of going straight from 0 to button binded to your commands for your subsystem, all right? So now let's go ahead and simulate this, all right? So I'm going to do simulate robot code. Okay, it's going to do its build thing, hopefully, yep. All right, and then we're going to use the real driver station, right, because we want to enable the robot. Okay, we've got our sim GUI up. Now here is what I want to show you, all right? So here's shuffleboard, all right? And you can kind of see what I like to do is sort of just make these bigger so I can see the command. So here we have intake % output, right? Nothing is currently running. These are your old tank drive % outputs, all right? So now what I'm going to do is I'm going to go ahead and enable the robot, and we're going to see what happens, okay? So I'm going to enable, and great, it's still at 0, right? I haven't run the command, now I'm going to run the command. And we can see, right, the intake % output, when I hit the plus button, which is our inward state, right? Here, let me drag this in real quick. We have an inward state. Now, there's a little bug that I just noticed with our printout that I'll explain in a second. But when I press the button to go inward, right, we see that the intake's current state is inward and the % output's negative 0.5. Now I'm going to hit the eject button. Look at that, right? Now it's approximating here, but this is 0.5 and our current state is ejecting, all right? Now the issue with this printout sort of is the fact that we don't have an intake state called idle, right? So when I let go of the button, what's happening is it's just going to keep printing out the last known value, all right? So that's okay for the case of sim, but that's just something to keep in mind, all right? So when I hit the plus button, we go inward. When I hit the minus button, we are ejecting, all right? And so, yeah, that's pretty much it in terms of going from absolutely nothing to having buttons completely binded for your intake subsystem, all right? Something else to keep in mind is that when you are using custom controllers, right, this button menu can change a lot, okay? That's why it's really important and highly recommended that, and let me just disable this real quick so my computer isn't lagging, but this is why I highly recommend and highly encourage that you define your constants for the individual controllers that you are using. So for example, right, if you have a 2-person drive team and you're using one controller to drive the robot and move it around, the other controller to move the robot's mechanisms, right? Let's just say you're using 2 controllers to control your robot, right? It's really encouraged, if they're not Xbox or PS5 controllers, that you actually go ahead and make, a static class for, let's say, your Nintendo Switch controller, right? And then define each of the buttons and their IDs as constants so that you can feed it in as constants later, all right? So instead of doing 10 and 9, well, I don't really know what that means without this comment, right? So rather than do that, we can make a constant that's like, K plus button, right? And then I can map that to the exact button ID that I get from driver station, all right? So that's something that I additionally recommend. Okay, so that about wraps up what I have for this video. Thank you so much for watching, and I look forward to seeing you in the next one.